All right, it's recording. Yesterday's lesson was called area under a curve, and today's lesson is called area above a curve. It's basically the same idea, except for the fact that when you're talking about an area that's below the x-axis, the integral here would be negative. See, integrals can be negative, but areas can't be. So if you're talking about the area and your integral has a negative value, you just you make it negative. That's one way to do it. I mean, if you were trying to change the sign of an integral, you could always just integrate it backwards from b to a instead of from a to b. That would also do the same trick. But basically what we do is we go, okay, I see this area happens to be below the x-axis, so I know that my integral will be negative. That's not allowed, so I'll just put a negative sign in front of it since I'm talking about area. Again, integrals can be negative, areas cannot be negative. If I just say find the integral and the integral's negative, well, hey, the integral's negative. That's all there is to it. But if I say find the area enclosed by, this must be a positive answer. Cool with that? Make sense? It's like saying a negative side length. It doesn't make sense. Negative area does not make sense. Okay. So the first question says find the area that is bounded by, instead of saying the area under the curve, we can say find the area that is bounded by the x-axis and this polynomial. Well, I can see that this is a cubic, and I can see that the front of this cubic is positive. That tells me it's shaped like this, generally speaking. So the only way that we could figure out the area that is bounded by this curve and the x-axis is if we knew where this curve interacted with the x-axis. Lucky for us, this factors. I can see right off the bat that it has a GCF of x. So we'll factor the x out first. Gives me x squared plus 2x minus 3. Oh, I'm be okay. I didn't even realize that it said it x equals 0 and x equals 1. Well, whatever. We're already going down this path. We might as well continue. This factors as well. The two numbers that multiply to negative 3 and add to 2 are 3 and negative 1. Because that's why. This curve crosses the x-axis 3 times. Once at 1, once at 0, and the other time at negative 3, but it didn't ask us about that. So what we have to know then is that it's going to look like this. Picture not drawn to scale, but imagine it looks like that. Okay. So there's 0, there's negative 3, there's positive 1. So there's x is 0, there's x is 1, and we are trying to find that area right there, which we can see is below the x-axis. Okay, well, we just integrate from 0 to 1, and we just put a negative sign on the front of it to guarantee that our answer comes out positive. Or, like I said, we could get creative and integrate from 1 to 0, because that would also change the sign of the integral. It actually doesn't matter which one you choose. Yeah, if you integrate from end to beginning, it changes the sign of the integral. That was one of the rules of, like, you could say the integral of a plus the integral of b is the integral of a plus b kind of thing. Yeah. This was one of them. It says if you switch the limits of integration, you change the sign of the integral as well. It would be nice if you understood that, but it's not really necessary. So our area will be equal to negative integral from 0 to 1, or I could have said positive integral from 1 to 0. Remember, I could have switched the limits of integration of f of x. So x to the third plus 2x squared minus 3x quantity dx. Because I didn't leave enough space, I'm going to have to do something I dislike, and that is do math horizontally. I'm sorry.
Weird.
I know it is. It's so odd. But I didn't leave myself enough space, so we're just going to have to go with it. It gives us negative. Now we can just spot integrate this. This exponent's going to creep up to a 4, and I tell you what, I'm going to put some parentheses. This exponent's going to creep up to a 4, so I need the reciprocal of its new exponent on the front. This exponent's going to come up to a 3, so I'll have to divide this 2 by the new exponent. That's the same thing as multiplying by the reciprocal, dividing by 3. Minus, same thing here. This exponent's going to come up to a 2, so I need this 3 to be divided by a 2. And we will integrate that, like I said, or evaluate that, excuse me, from 0 to 1. Now, it really doesn't matter, honestly. You could either distribute the negative sign and then evaluate and subtract, or you could evaluate and subtract and multiply by negative 1. You're going to get the same result. It doesn't matter. I'm sorry? No plus c because we have limits of integration. Now, here's the thing. If we did write plus c, you know there would be a evaluating with a 1 and evaluating with a 0, and they would both end with a plus c, right? And when you subtract, the c's would have canceled out. So it's not that they don't exist, it's that there's no point in ever writing it because they're going to cancel each other out. Okay? That's only because we have limits of integration. Yep.
How are you supposed to know if you're finding the area above or below?
An area above or below?
Yeah.
Well, it's kind of, if they don't give you a picture, it's on you basically to sketch it.
But like the wording is the same, like on the last question, it's like
Yeah.
total area enclosed.
Well, okay. But so when it says total area enclosed, the implication here is that there's a good chance that some of those areas are above while the others are below. So you'd have to work at it and in pieces. Okay. So that's what I'm saying. If they don't give you a picture, you probably need to come up with a picture, which is why I went ahead and did this. Because this one also could have said total area enclosed, and we would have had to have figured out what that area is and add it to this area. But this one just said from 0 to 1, so we're only focused on that one. All right, tell you what I'm gonna do. I want to evaluate first, subtract, and then just multiply by negative 1. You guys cool with that? Okay. So equals. I'll do the negative sign afterwards. So first things first, plugging in a 1 to all of this is going to give me a 1/4 plus 2/3 minus 3/2 minus, now you plug in a 0 everywhere. Oh, look, it's just going to be 0 plus 0 minus 0. So it really does nothing. So yeah, so this doesn't even, that means nothing. Distribute your negative 1, you'll get negative 1/4 minus 2/3 plus 3/2, and hopefully I didn't goof this up too bad. What's our GCF? 12?
6.
No, 4 doesn't go into 6. Pretty sure the GCF is 12. It's a good try though. I'm sorry? I distributed this negative sign.
Wait, why is the negative sign there?
It's this negative sign, which is this negative sign,
Yeah. Where's that from?
because the area is below the x-axis,
Oh, okay.
and we can't have a negative area. So we either have to have a negative sign here, because we see that it's below the x-axis, we either put a negative sign in front of the integral to guarantee that we get a positive result, or switch the limits of integration. Do one or the other, it doesn't matter which one you choose. This is the one the authors go with. So 12ths, right? So we have negative 3/12 minus 8/12 plus 18/12. Did I do my math right? Looks like 7 over 12.
Yeah.
Yay! That's the total area bounded by that curve, the x-axis, and x equals 0 and x equals 1. Ta-da! Neat.
560 degree.
Did someone say question?
No, the next one's the same question.
No, it's not. You'll notice the next one did not say from x equals 0 to x equals 1. The total area. So then here's what we know. We know that this area right here has a value of 7 over 12. All we need to do now is find this area, which we know because we did the hard work early, goes from, hey, clowns, goes from -3 to 0. And because it's the x-axis, above the x-axis, we don't need to say negative. So tell what we'll do. We'll say that this one here is area 1, and come back and say A1 equals. And we'll say this one here is area 2, so we can say A2 equals. How about that? And then we'll just add them together to get the total area. Yeah? Good? All right. Let's find the total area bounded by. Okay, well, here's what we know that's going to do. We know that the total area would have been equal to the integral from -3 to 0 of f of x dx. That's this one. That's A2. And then plus this area. But remember that this area was represented by minus the integral. We all clear with what I just said? So it's actually going to be minus the integral from 0 to 1 of f of x dx. Because this represents what we just found, A1. This represents A2. And we're just going to add those two things together in a moment. We already know this is going to give us a 7 over 12, so we don't even need to putz with that.
Why are we subtracting?
Hold on. Again, did you see right here that this integral was negative because it's below the x-axis? Gavin? The value of this is that.
Yeah, but
when you add a negative, aren't you actually subtracting?
Yeah.
Okay, here's me adding this negative integral. This integral is negative because this area is below the x-axis.
Oh, so when you put out the negative, it'll actually be adding it.
Because this actually has a value of positive 7/12.
With the negative sign?
With the negative sign, because look, there's the negative sign right there.
Yeah.
Yeah, so this integral is this green integral. It ends up having a positive value because we put that negative sign in front of it. So what I've done here is I've added A1's integral. It just so happens that A1's integral has a negative sign in front of it. But I did still add them together. Adding a negative is the same as subtracting. Yeah?
Yeah, I just don't know why you, like...
Okay. How about this? Can we agree? Yeah, I just got to come up with a different way of saying it. Can we agree that A2 is the integral from -3 to 0 of f of x dx?
Yeah.
Can we agree that A1, because it's below the x-axis, in order to get a positive answer, I have to say negative?
Yeah.
Okay. Integral from 0 to 1 of f of x dx? Because this was 0 and this was 1?
Yeah.
Again, it's negative because it's below. Can we agree that the area is A2 plus A1?
Yeah.
So then we can agree that the area then is the integral from -3 to 0 plus this integral.
Oh, okay.
But when you say plus a negative, you're actually just saying minus.
So, if the area... I know, that just messes with my head because, like, the area, like, looks like it's really smaller than what it actually is, though.
Well, don't worry about its size. The picture not drawn to scale. Just worry about whether or not it's above the x-axis or below the x-axis.
Okay.
Okay? So, more comfortable now?
Yeah.
Okay. All right. Makes for good notes anyway. Alrighty. Since we've already done this part here, we only need to do this part. We don't need to reintegrate. We already know what this integrates to. It's right there. It integrates to the exact same thing, just with different limits of integration. We comfortable with that idea? So I don't have to redo the integral? Great. So this is going to be equal to negative, and then I've got the same integral, 1/4 x to the 4th. Oop, oop. Scratch that. There's no negative sign. My apologies. That negative sign belonged to this integral only. I am so sorry. And that one's being evaluated from -3 to 0. And we know that the other integral, this negative integral, has a value of 7/12 from the previous answer. I just want to make sure we're all good on that. We're good on this? I need to plug in 0 and then subtract me plugging in -3. But look what happens when you plug in 0. You get 0 again. But be careful. Remember, it's minus the second evaluation. It's minus the second evaluation. So it's going to give you 0 minus, now you plug in -3 everywhere. And when you plug in a negative number, you're going to get an even. So this is going to be 3 to the 4th, which is 81. Comfortable with that? This is going to be positive 81/4. Here, when you cube a negative, you're going to get a negative.
Wait, this is a question.
Yes.
Why aren't we subtracting?
Oh boy. You missed the entire thing that I showed Gavin, didn't you?
Well, no, I
Here,
did.
I'll show. Look. I'll show it again. She was talking that time. Okay.
Oh, wait, because it is 7/12 is the negative.
Because the negative integral is the value 7/12. Okay. Yeah, that's why. Anyway, what are we doing? Oh, plugging in -3. Yeah. So -3 to the 3rd is -27. 27 times 2 is 54. Of course, I could reduce this, but whatever. Minus, square this 3, you get a 9. 9 times 3 is 27. Over 2, yuck. And then again, here's that plus 7/12. Who likes fractions? Decimals. Monster. Monster. I don't know what 7/12 is as a decimal. Once again, the common denominator is going to be a 12. So that's going to be horrific. That's going to be 243/12. So you have -243/12. Ugh. This is going to be a plus at least, because it's minus a negative. Plus 216/12. Okay, good, thank you. I'm pulling these numbers out of my brain here. Oh, plus again. Man, 162. Okay. And my brain's tired. Can someone just tell me what those numbers add up to?
I got 142/12, 7/6.
What'd she say?
142.
142/12? Yeah. Which is 71/6. Wow, that was fun. Oh, wait, no, the other word. Tedious.
Yeah.
But there you go. Now, I think that I would like to teach you something early. I'd like to teach you something early. Your calculator can integrate this for you. And it could Yeah, but you have to know how to do it by hand as well, because the next test I think is a, can't remember if it has both parts or just no calculator. But you should still know how to use your tech to check your answers. Okay? So let's, I'm trying to teach here. What we're going to do is we're going to say math and then f in integral. So it's math 9. We're going to say from -3 to 0. We have to type in our function. So x cubed plus 2x squared minus 3x. And that's dx. And now you do minus math 9 and you just retype the stuff. Minus math 9. And that was from 0 to 1 of the exact same function. And when we hit enter, I'm hopefully going to get a number that's a little bit bigger than 11, close to 12. Yay! Close to 12. That is 71 divided by 6. Now, wait for it. There's an even more efficient way that this calculator could do this for us.
Absolute value.
Absolute value. Now, we do not have the ability to integrate absolute values by hand, but the calculator does. If we set absolute value of this function between -3 and +1, realize that the entire red area would actually have been reflected above the x-axis. So an even more efficient way would be math 9 from -3 to +1, and in these parentheses, you do math number ABS, absolute value. X raised to the third plus 2x squared minus 3x, still dx, and it should give us the exact same answer because it took the negative areas, reflected them above the x-axis to pull this off. So much more efficient way of checking our answers. We do not have the ability to integrate absolute values, but we do have the ability to split a region apart and then say plus that region or minus that region. Okay. You know what? I'm going to use some more space. I'm just going to flip the notes over and put this on the back. Pi over 2 and 2 pi. 2 sine x. Let's move it over to the back where there's more space. Total area, f of x equals, it was 2 sine of x, right? And that is from, is it pi over 2 to 2 pi? So to answer Bria's question from earlier, you would need to graph this to figure out where this thing is above the x-axis and where this thing is below the x-axis. That way we can split the region appropriately and integrate the two different areas, giving the regions that are below the x-axis a negative sign in front of them, and the regions above, we just say plus that region. So 2 sine of x has an amplitude of 2. So we'll just cheat and do that. And has a period of 2 pi. Oh, check that out. So what we have here is a positive area 1 and a negative area 2. So we will have to subtract the integral from pi to 2 pi. Hold on. You're about to say something profound. I need to make sure everybody's listening. Anyway, you were saying? So what he's saying is because of the fact that it's a sinusoidal and it doesn't have any kind of weird transformations on it, if we hadn't split this region in half, this positive region would be exactly equal to this negative region. In fact, the integral from 0 to 2 pi of sine of x is equal to 0, because the positive area is exactly the same as the negative quote-unquote area, so the integral has a value of 0. So what we can do, thinking smarter not harder here, instead of finding this region integrated and evaluated, and then find this region integrated and evaluated, we could just find, say, area 1 and then triple it, and we'll be done.
Triple it.
Because imagine area 2 is 2 area 1s.
Right, why do that? Why don't you just,
Because area.
Hold on. Let her finish the question. Why don't you just what?
but why don't you just take the area of the whole thing rather than splitting it in half?
Well, because we were told to.
Oh, okay.
That's the only reason why.
You times it by 3, not 2.
Well, think about it.
Are you?
There's 2 identical regions here, correct?
Yeah.
Okay, put your phone down for a second. Pay attention. Close the camera. Stop taking pictures. Okay. Can we agree that all 3 of these things are equivalent?
Yep.
Then wouldn't I just find one area and multiply by 3?
Oh, to add, okay, the whole. Okay.
Instead of finding the 2
I thought-
areas
I thought
individually.
You meant, I thought you meant area 1 times 3 equals area 2. Not
No. Area 1 times 3
Okay.
equals area.
Okay.
Area 1 times 2 equals area 2.
Okay, yeah, that's why you tripped me out.
Right.
Why is that?
So the total. So picture not on the scale. I did a bad job of chopping this hump in half. From 0 to pi, pi over 2 cuts it in half. So area 1 is exactly half of this hump. This hump is equivalent to this hump. So area 1 is this, and it's also this. So I could just take area 1, I could find area 1, and I could triple it. And it would give me this, this, and this. Cool? Okay. So our area is equal to 3 times the integral from pi over 2 to pi of 2 sine of x dx. So it's actually a lot easier than it looks because of the fact that it's trig. Now, if I had picked different limits of integration, say I decided to go with 2 pi over 3, this trick wouldn't have worked. You would have had to have found them individually and added the 2 individual areas together. But we're trying to think smarter, not harder here, because you know that's how IB kind of stuff does. Guys, Jesus. This right here, this 2, because it's a constant, can actually be scooted to the front. There. We just need to integrate sine of x. I say, well, sine of x is the derivative of negative cosine. So this gives us negative 6 cosine of x evaluated from pi over 2 to pi. So we plug those numbers in and subtract. Yes. Absolutely matters. Top minus bottom, always. It's always end minus beginning. Think about it. If you start at 2 and went to 10, how far did you go? 10 minus 2. It's always end minus beginning. Top minus bottom. Gavin, quit with the phone. I don't care what you're doing. Sure? Okay. That gives me negative 6 cosine of pi. Watch this now. Minus negative cosine of pi over 2. So you would just 6 cosine of pi over 2. So you would just need to be able to evaluate cosine. You can either see the graph in your head, or you can know that cosine is x over r. At pi, on the unit circle, x is negative 1, r is 1. So this is negative 6 times negative 1 plus 6 times what? Pi over 2. On the unit circle, you're on the y-axis. There is no x value. Six. So what that tells us is, for the curve that I drew, area 1 equals 3. No, 2. There we go. I can divide. Area 1 is 2. Area 2 is 4. Together they make 6. And there you go.